Hello everyone. This is our first lecture of Oscillator lecture series. In today's lecture, we will understand one of the most important oscillator circuits, the phase shift oscillator. So what is an oscillator? An oscillator is an electronic circuit that converts a DC power into a continuous AC signal without requiring any external input. It only needs a DC supply, but due to positive feedback, it keeps producing a sinusoidal waveform. The basic principle is based on the Barkhausen criterion. So, for sustained oscillation, two conditions must be satisfied. First is total phase shift is equals to 360 degree or 0 degree, or you can say that 2 in pi, where n equals to 0, 1, 2, 3 bets. And the second is the loop gain, which is modulus of A beta is equals to 1. Now the question is, where does this 360-degree phase shift come from? That exactly what the phase shift oscillator does. The circuit consists of two parts, a transistor amplifier, three identical sections connected in cascade. The transistor amplifier is a common emitter amplifier. A common emitter amplifier naturally introduces a 180-degree phase shift between input and output. So, amplifier phase shift is equals to 180 degree. Each RC sections contribute approximately 60 degree of phase shift. So RC section provides 60 degree plus 60 degree plus 60 degree equals to 180 degree phase shift, right? So therefore, adding with the amplifier phase shift, we get the total phase shift is equals to 360 degree. Thus the Barkhausen phase condition is satisfied. Now the working principle of phase shift oscillator. When power is switched on, a small amount of electrical noise is present inside the circuit. This tiny signal is amplified by the transistor. The amplified signal passes through the RC sections. The RC network shifts its phase by 180 degree and feeds back to the transistor's input. Since the feedback is positive, the signal becomes stronger after every cycle. Finally, when the loop gain becomes unity or 1, the amplitude stabilizes and the circuit generates a continuous sine waves. So this is the circuit diagram, and we have to convert this circuit into its AC equivalent model. So this is the AC equivalent model of this circuit, and here you can see the resistor is R minus HI. Why I am taking this? You will understand it later. And you can see the R1, R2 resistor is connected between the base and emitter junctions, and the RC and the remaining RC sections are connected between collector and emitter, and the last resistor is connected between collector and base. So here you can see that HIE and HFEIB, the current source is taken from the internal structure of BJT. So now calculate the input impedance. So see from there, and we will get the input impedance equals to R1 parallel R2 parallel HIE. Here HIE is very small from R1 and R2. So we can approximately written as HIE. So simplify this circuit, and now you can see that R minus HIE is connected series with HIE. So when we simplify this, R minus HIE plus HIE gives R. That's why I take that resistor as R minus HIE for simple calculations. And here you can see the current source is connected parallel with that RC resistor. And according to the source transformation law, you can convert this current source into a voltage source series with that resistance. So simplify this and we will get that circuit. So here we can see that is the voltage source connected with series resistance and the remaining RC sections, and you can see that R minus HIE plus HIE gives resistor R. And now we have to analyze this circuit to calculate the frequency of oscillation and HFE. Now this circuit, from this circuit we get three KVL equations: I1, I2, and I3. The three equations are RC plus R plus J, sorry, plus 1 by J omega C into I1 minus R I2 plus HFE I3 RC is equals to 0. The second equation is minus R I1 plus 2R plus 1 by J omega C I2 minus R I3 equals to 0. And the third equation is 0 minus R I2 plus 2R plus 1 by J omega C into I3 is equals to 0. So now the three equation is converted into matrix multiplication form. So RC plus R plus, now we take that J into the numerator and the sign will be negative. So minus J by omega C minus R plus HFE RC minus R 2R minus J omega C minus R 0 minus R 2R minus J by omega C into I1, I2, and I3 equals to 0. As the matrix multiplication value is 0, thus the determinant of this matrix also be 0. So copy this. So determinant of this matrix will be 0. Now solve the determinant. Taking I am taking that column for simple calculations. So RC plus R minus J by omega C 2R minus J by omega C whole square minus R square plus R minus R into 2R minus J by omega C and plus HFE RC into R equals to 0. Now solve this square form. RC plus R minus J by omega C 4R square minus 1 by omega square C square minus R square minus 4RJ by omega C plus minus R square 2R minus J by omega C plus HFE RC R square. Now multiply this equation. You can get 4R square RC minus RC by omega square C square minus R square RC minus 4R RC J by omega C plus 4R cube minus R by omega square C square minus R cube minus 4R square J by omega C minus J by omega C second bracket 4R square minus 1 by omega square C square minus R square and multiply this J terms and we will get 4R minus 4R by omega C omega square C square minus 2R cube plus R square J by omega C plus HFE RC R square equals to 0. So now separate the real and imaginary part. So 4 R square RC minus RC by omega square C square minus R square RC plus 4 R cube minus R by omega square C square minus R cube minus 4R omega square C square minus 2R cube plus HFE RC R square equals, sorry, this is the real part, this is the real part, and the imaginary part will be minus J by omega C 4 R RC plus 4 R square plus 4 R square minus 1 by omega square C square minus R square minus R square equals to 0. Now, if the addition is equals to 0, then the imaginary part also 0 and the real part also 0. Then taking the real part, sorry, imaginary part 0. So this equals to 0 or 4r RC plus 4r square plus 4r square minus 2r square equals to 1 by omega square c square. So omega square c square equals to 1 by 4r RC plus 6r square. So omega equals to 1 by c root over of 4r RC plus 6r square. And the linear frequency will be 1 by 2 pi c root over of 4 RRC plus 6 R square. So this is the frequency of oscillation of phase shift oscillator. And if RC is equals to R, then 1 by omega square c square is equals to 10 R square, right? So frequency will be 1 by 2 pi RC root over of 10. Now taking the real part equals to 0. So this is equals to 0 if RC is equals to R, then 4R cube minus R cube plus 4R cube minus R cube minus 2R cube minus 6R by omega square c square is equals to minus HFE RC, sorry, R R cube. So 4R cube minus 6R. As we know that 1 by omega square c square is equals to 10R square. So 10R square equals to minus HFE R cube. So minus 56 R cube equals to HFE minus R cube. So HFE will be 56. Thank you for watching. If you found this lecture helpful, please like, share, and subscribe to Semicode. The PDF of today's slides are available in the description below. See you in the next lecture.